Hello, my name is Geoff Raifsnider. I'm a senior mechanical engineer with Global Finishing Solutions, and today we will be covering common questions regarding paint storage and use. Now, the questions we will cover: how much paint can I have in my facility? When do I need a mix room? When do I need a hazardous material storage building? Do I need ventilation? How much and when? What is the electrical area classifications? Do I need an explosion control method? Before we get into the questions, there are a couple key concepts and definitions I'd like to cover. The main reason we are having the discussion is that most paints are considered either a flammable or a combustible liquid. Under the right conditions, these liquids can produce vapors that can ignite and may result in a fire or a deflagration. And because of the risk of fire and deflagration, codes and standards have been developed to help minimize the hazard and protect people and property. These codes and standards include NFPA 33 standard for the spray application using flammable or combustible materials, NFPA 30 flammable and combustible liquids code, the International Fire Code in the United States, and the National Fire Code in Canada. The requirements we reference in the responses today can be found in each of these documents. Important characteristic for the application of the requirements is the classification of the liquid. The classes are broken down based upon their flash point and boiling point. Flammable liquids are classified as follows. Class 1A liquids, any liquid that has a flash point below 73 degrees Fahrenheit and a boiling point below 100 degrees Fahrenheit. Class 1B, any liquid that has a flash point below 73 Fahrenheit and a boiling point at or above 100 degrees Fahrenheit. Class 1C, any liquid that has a flash point at or above 73 Fahrenheit but below 100 degrees Fahrenheit. Combustible liquids are classified as follows. Class 2, any liquid that has a flash point at or above 100 degrees Fahrenheit but below 140 Fahrenheit. Class 3A, any liquid that has a flash point at or above 140 degrees Fahrenheit but below 200 degrees Fahrenheit. And Class 3B, any liquid that has a flash point at or above 200 degrees Fahrenheit. And the last item I want to cover before we get into the questions are definitions of control area and maximum allowable quantities. Full definitions for each of these can be found in both NFPA 30 and the International Fire Code. But for the purposes of today's discussion, we will boil it down to the following. Control areas are separated by fire barriers, which are fire resistance rated assemblies. And maximum allowable quantity, or MAQ, is the threshold amount of material before additional measures are required to mitigate the hazards. This is where the class designation becomes important, as the MAQs varies based upon the class of liquid. So let's start with questions about how much paint can I have in my facility. This is where the maximum allowable quantity, or MAQ, comes into play. The MAQs can be found listed in NFPA 33, NFPA 30, and the International Fire Code. For example, if the paints you have are Class 1B and the MAQ is 120 gallons for Class 1B liquids, this means that you would be allowed up to 120 gallons within a control area without having to do anything special. However, if your building is equipped throughout with an approved automatic sprinkler system, you can increase that amount by 100%. So in the case of Class 1B liquids, you would be allowed up to 240 gallons. And there is another method to increase the MAQ. If stored in approved storage cabinets, day boxes, gas cabinets, gas rooms, exhausted enclosures, or enlisted safety cans, the total amount can be increased by another 100% to 240 gallons. So if you store in these enclosures and the building is equipped with an approved sprinkler system, you get to count both increases, and your total would be up to 360 gallons of Class 1B liquids. So before we get into the next set of questions, let's discuss a couple types of ventilated enclosures that GFS offers. They are paint mix rooms and hazardous material storage buildings, formerly known as paint kitchens. These types of enclosures are designed to accomplish two things. First, to help increase the amount of materials you can have in your building, and second, to contain operations that are required to be performed in an exhausted enclosure. The first type of enclosure we offer is the paint mix room. You can find the design, construction, and operational requirements for mix rooms in Chapter 8 of NFPA 33. Highlights of the requirements include: the floor area of a mix room shall not exceed 150 square feet. If located more than 6 feet from a spray booth, the amount of liquid in a mix room shall not exceed 2 gallons per square foot, regardless of the class of liquids present. If located adjacent to or within 6 feet from a spray booth, the combined amount of liquids in a mixed room and the adjacent spray booth shall not exceed 120 gallons or 2 gallons per square foot of the mixed room area, whichever is less. And it's worth noting that the maximum quantity of liquids within a spray booth is 60 gallons. And again, these limits are regardless of the class of liquids present. Requirements also in Chapter 8 include electrical area classification based upon location of sources and minimum ventilation required being 150 cubic feet per minute when vapors are present. The second type of enclosure we offer is the hazardous material storage building or paint kitchen. These are often referred to as flammable storage buildings or hazardous material storage lockers. You can find the construction, design, construction, operational requirements for hazardous material storage buildings in NFPA 33 and the International Fire Code. Highlights of the requirements include fire-rated construction based upon the size of the storage building and if it is located indoors or outdoors, designed to be capable of containing more than the MAQ, electrical area classification, again, based upon the location of the sources, and where dispensing or filling is performed, the minimum ventilation requirement is 1 cubic feet per minute per square foot of floor area or 150 cubic feet per minute, whichever is greater. So that leads us into a next set of questions. When do I need a mixed room or when do I need a hazardous material storage building? Again, it depends. So to help answer these questions, let's go through a couple examples. Let's say you have an operation that involves transferring liquids or mixing of different liquids into one container. The liquids are Class 1B and the quantity you have is 100 gallons. Even though you are below the maximum allowable quantity of 120 gallons of Class 1B liquids, per NFPA 33, this type of operation must be performed either in your spray booth or with, spray booth with the ventilation on or in a mix room. If dispensing or mixing operations can be performed in a mix room with a floor area of more than 50 square feet, then you will also be under the 2 gallon per square foot limitation for a mix room in this example. So now let's say you have the same operation, but the total quantity of Class 1B liquids is 440 gallons. You are now over the MAQ limit. Even though the operation must be in a ventilated enclosure and maybe you have your building and enclosure are fire protected, the MAQ only increases to 360 gallons of Class 1B liquids. In this case, we can use a hazardous material storage building to create separate control area from the rest of the building. As we mentioned, hazardous material storage buildings are constructed to have both fire-rated walls and fire-rated ceilings, and therefore meet the requirements for enclosing a control area. Something to note here, even though we have contained the operation and the materials within a control area, we are still over the MAQ. But that's okay. The codes and standards state that when you exceed the MAQ for flammable or combustible liquids, the occupancy classification of that control area becomes either a high hazard group H2 or H3. With the difference between them being that the occupancy would be H2 if you had to close containers or pumping systems pressurized to more than 15 psig, and H3 if pressurized at less than 15 psig, pounds per square inch gauge, or less. So let's talk a little bit about the mix rooms and address some specific questions. First, how much paint can I have in a mix room? As we touched on the previous example and in the overview of the code requirements, the answer is a function of the mix room floor area and location. If located adjacent to or within 6 feet of the spray booth, the combined amount of liquid in a mix room and the adjacent spray booth shall not exceed 120 gallons or 2 gallons per square foot of the mix room floor area, whichever is less. So for example, a 8 by 10 mix room that is located adjacent to the spray booth could contain up to 2 gallons per square foot for a total of 160 gallons. However, due to being located closer than 6 feet to your spray booth, the combined capacity of the spray booth and the mix room is limited to the 120 gallons. Based upon the size of the room, an 8 by 10, all 120 gallons could be in that mix room. If located more than 6 feet from a spray booth, the amount of liquid in a mix room shall not exceed 2 gallons per square foot. So for the same 8 by 10 mix room, but located more than 6 feet away from your spray booth, the maximum capacity is 160 gallons. A question that sometimes follows, how much paint can I have in a mix room, is how many mix rooms can I have? And the answer is you can have as many as you like. However, it may not have the effect on the total that you were hoping for. So for example, if you had the largest mix room, which is 150 square feet, and it was more than 6 feet away from your spray booth, you could have up to 300 gallons of paint in that single mix room. If you purchased another 150 square foot mix room to be placed in the same control area, you are still limited to 300 gallons total between them. This is because mix rooms do not qualify as control areas since they are not constructed to have a fire rating. To answer the next common question, this one has been affected by recent changes in NFPA 33, and that is, what are the ventilation requirements for a mix room? And again, it depends. It now depends. We still have the requirement for a minimum of 150 cubic feet per minute, but now, with the recent changes, ventilation is only required when you have open use of Class 1, Class 2, or Class 3 liquids that are at temperatures at or above their flash point. Class 1A and 1B liquids, as we pointed out before, have a flash point below 73 degrees Fahrenheit. So it is likely that the operation will be conducted in your mix room at or above the flash point of those liquids. Therefore, ventilation shall be provided during operating hours or whenever the vapors are present. Same may be true for some Class 1C liquids that have flash points near the ambient temperature of your mix room. If your operation involves Class 2 or any of the Class 3 liquids, and they're not heated above their flash point, then you are not required to have mechanical ventilation, or if your mix room has ventilation, you can turn it off. Our last question regarding mix rooms, what is the electrical area classification of the interior of a mix room? And again, the answer to this question has also been affected by recent changes to NFPA 33. The electrical area classification of a mix room used to be the same as a spray booth. It was Class 1, Division 1 throughout. And the conservative approach would be to continue to consider the area of your mix room to be Class 1, Division 1 throughout. However, the standard allows you to look at the layout of the sources in the room and apply the guidelines in NFPA 30 to establish potentially different electrically classified areas within the mix room. There may be some cost advantages to this approach. However, if you choose to take advantage of this revised requirement, it is important that you do so through a thorough review of the sources within the room, and you ensure that they remain in the locations you identified. Any change in the source would require a reevaluation of the area classifications and may result in modifications to the wiring or the location of any electrical equipment. The standard construction of GFS mix rooms has not changed and will remain suitable for those situations where the area within is considered Class 1, Div 1. Now let's cover some specific questions specific to the hazardous material storage buildings. Let's start with, again, how much paint can I have in a hazardous material storage building? As we covered before, because of the construction of the storage building, we are not necessarily limited by the maximum allowable quantity limit. However, the amount is a function of the design of the storage building and the type of fire protection used. Size of the largest liquid container in your storage building may also be a factor. These storage buildings are required to have a sump size to contain 20 minutes of sprinkler discharge, as well as the spill of the largest container. There are also factors in the storage density that may drive the maximum capacity. Additional capacity may be available for the same size hazardous material storage building protected by a dry chemical fire protection system, since the dry chem does not affect the holding capacity of the sump. So for comparison, 16-foot by 8-foot mixed room has the capacity to hold 256 gallons. An equivalently sized GFS hazardous material storage building has a maximum capacity of 550 gallons when protected by a sprinkler system and 625 gallons when protected by a dry chem system. GFS publishes the capacity of our standard size hazardous material storage buildings for both sprinkler and dry chemical fire protection systems, and if you have custom sizes, we can provide you that information for the custom sizes. And just like mixed rooms, we often get the question, what are the ventilation requirements for a hazardous material storage building? The requirements are now similar to that for a mixed room. The current version of NFPA 30 requires mechanical ventilation systems only for where Class 1 liquids are dispensed. However, the International Fire Code requires ventilation where quantities have exceeded the MAQ. In both codes, the ventilation rate is 1 cubic foot per minute per square foot of floor area, but not less than the 150 cubic feet per minute. Both codes allow natural ventilation to be used where it is shown to be effective for the materials present. Also, like mixed rooms, we are often asked, what is the electrical area classification of the interior of a hazardous material storage building? And again, it depends upon the location of the vapor sources. As we mentioned, with regards to the change for mixed rooms, the approach to determining electrical area classification for hazardous material storage buildings can be found in NFPA 30. Often these buildings are larger and have more space between vapor sources. Like mixed rooms, there may be some cost advantages to applying this approach. It is important that you do a thorough review, as I mentioned before, of the sources in the room and make sure that the sources remain in the locations you've identified. The standard construction for GFS hazardous material storage buildings has not changed and will remain suitable for those situations where the interior is considered a Class 1 Division 1 location. We do offer some accessories such as air conditioning units that can be selected for Class 1 Division 2 locations within the storage building. But if needed, GFS can offer other air conditioning solutions where Class 1 Division 2 units are not suitable for your layout. And a final two-part question with regards to hazardous material storage buildings, which has only lately become more frequent. Do I need an explosion control method for my hazardous material storage building? And if I do, what method is appropriate? The answer to these questions depends upon the location of the storage building, the types and amounts of materials present, and if it is used for storage, open use, closed use, or a combination thereof. The first part of the question, do I need an explosion control method, can be answered based upon the class of liquids, the amount of liquids, and whether you are storing only or have open use. The International Fire Code requires an explosion control method where you have exceeded the MAQ for storage or use of 1A liquids, or where you have exceeded the MAQ for open use or dispensing of 1B liquids. A hazardous material storage building would not require any method of explosion control where the contents are Class 1C, Class 2, or the Class 3 liquids. Explosion control would also not be required for storage or closed-use systems involving Class 1B liquids. The International Fire Code provides guidance on what is considered a closed-use system. When it has been determined that some form of explosion control is required, there are two common methods to be used: deflagration venting and deflagration prevention through concentration reduction. Deflagration venting, or explosion venting, is the simplest method, but requires deflagration to be vented outside your building. Locating the storage building indoors requires the storage building to be placed along an exterior wall where the deflagration vent panels can be lined up with penetrations in the building wall. Deflagration prevention through concentration reduction requires a hazard analysis based upon the types of materials present. The result is a determination of any additional airflow required to reduce the concentration of flammable vapors present during a spill or other accidental release of the materials. The analysis requires review of all safety data sheets for the materials that will be in your storage building. Deflagration prevention systems also require frequent maintenance and calibration of the equipment to ensure the system continues to provide the required level of protection. GFS does provide this hazard analysis to help determine the best solution for the situation. Thank you, and that covers the frequently asked questions that we've received regarding paint storage, use, and the enclosure solutions GFS offers. Hopefully we've addressed your questions. If not, you can reach out to us at globalfinishing.com or post your questions in the comments below. Thank you.